we will start with the chemical decomposition. Okay, better start.
Ma'am, can I, Delisha?
Sure, sure.
The
Make it
chemical
fast. Make it
decomposition of a liquid or a solution while passing an electric current is called electrolysis.
electrolysis. Say it again.
Electrolysis. Electrolysis. The liquid or solution that breaks up during electrolysis is called electrolyte. An electrolyte, when dissolved in water or when melted, produces ions. These ions are free to move throughout the solution. The positive charge ions are called cations, and
Cations.
the
Read it again. Cations.
cations, cations, and the negatively charged ions are called anions.
Anions. Anions.
Anions.
Okay, fine. Now, for example, this is a liquid. It's in the beaker. Okay, this is a liquid. Okay, beta. And there are two electrodes. What do you say? Okay. Now, this liquid, which is in which the electrodes are inserted or immersed, this liquid is called as electrolyte. What it is called as?
Electrolyte.
All of you understood now?
Electrolyte.
The liquid which I'm keeping it in a beaker and where I've immersed the electrodes, it is called as electrolyte. What is happening? I'm making a circuit. I'm putting on the circuit. What is happening? There's a chemical decomposition of this electrolyte. Agree? So electric current is passing through the solution. Agree or not?
Yes.
Hello? Yes. So there's a decomposition of a liquid. It is breaking down. It is breaking down into what? It is breaking down into ions. What it is breaking down, beta? Ions. Is it clear? So it is producing ions. Now these ions are free. They can move anywhere. There are two types of ions. One is positive charge, which is called as cations, and one is negative charge, which is called as anions. What it is known as? Positive
And
charged cations, negatively charged anions. You understood now?
Yes, ma'am.
Whereas, whereas the electrode which is positive is known as anode. What it is known, beta? Anode. And the electrode which is negative, it is known as cathode. Is it clear?
cathode. Yes.
Is it clear?
Yes.
But
Yes.
the ions are opposite. Now, cathode is negative electrode, but cations is what is cations, beta? Positive ions. Anode is positive electrode, but anions is negative ions. Do you understand? This is how you have to remember.
Yes.
Okay, fine. Any problem regarding this slide, beta?
No,
Be
ma'am.
fast. Okay. Now, same thing, revision, electrolysis of water. Please continue. If someone else wants to read, can do that. Otherwise, Delisha, continue. If no one is taking up the charge, then you continue.
Okay, ma'am.
But
Electrolysis of water. When electric current is passed through water, it splits up into
split.
hydrogen and oxygen. This is
Hmm.
called electrolysis of water. When electric current is passed through water, oxygen gas bubbles are produced at the electrode connected to the positive terminal of the battery, and hydrogen gas bubbles are produced at the electrode connected to the negative terminal of the battery.
That's, you can see here, electric current is passing. Got it? Now, this is one electrode, cathode, so it is negative. What is it? Negative. This is anode, this is positive. Agree? Do
Okay.
you agree? With the help of
Yes.
battery, I am passing the electricity through it. I am passing the electricity through the solution. Now, this solution is called as electrolyte. What is this solution, beta? Electrolyte.
Electrolyte.
All of you agree?
Yes.
All of you agree?
Yes.
Okay, this is water. So, what is happening? The water is made up of H2O. Is it clear? So, H
Yes.
becomes plus and oxygen becomes minus. So, where the minus will go? Any idea? Minus will go to anode and plus will go to cathode. You agree?
Cathode. Yes.
Understood or not? H plus. Now what is H plus? It is cations. What it is? Cations. So cations will go where? Where will it go? Cathode.
But
Yes? Hello? And anions
Yes,
is
ma'am.
negative. Where will it go? Anode. Is it clear now? So it will get
yes.
deposited. See how? You can see the deposition over here. Can you see this deposition, beta? See, these are the deposition in form of bubbles. Can you see this? These are all bubbles. Understood, all of you? So this is how you can do the electrolysis of water. Same thing over here. You can see the gas filling up in the test tube. See, this is oxygen gas and this is hydrogen gas. The water is being split into oxygen gas and hydrogen gas. Now this is anode. Which is this? Anode. Now anode is positive and cathode is negative. Now H is plus and oxygen is minus. So minus goes into plus and plus goes into minus. Is it clear?
Yes, ma'am.
Is it clear? Okay. Now, electrical conductivity of other liquids. Now we have seen water. We know it can conduct electricity, tap water. But distilled water cannot conduct electricity. Why? Because distilled water does not have any salts, whereas tap water has got salts in it. Is it clear?
Yes, ma'am.
Is it clear? Okay. Now
Electrical
we will
con-
see whether. uh, Continue with it.
Electrical conductivity of other liquids. Many liquids are good conductors of electricity. Several acids are bases when dissolved in water become good conductors of electricity. Lemon juice, vinegar, aqueous,
Sodium
aqua,
chloride.
what
Sodium
ma'am?
chloride. Sodium
Sodium
chloride.
chloride and aqueous potassium chloride.
Potassium chloride. They are
Potassium chloride
examples. They are
are a few
examples.
examples.
Now, we know that there are lots of liquids which are conducting electricity. Know there are acids, we know there are bases. When we dissolve in water, they become good conductors of electricity. That we have already seen. Lemon juice. What is lemon juice? Acid. Vinegar. It is acid. Aqueous sodium chloride. This is base. What is sodium chloride, beta? It is salt. Isn't it table salt? So it is base. That's why we can have it. Aqueous potassium chloride, that is also base. Now, these are few examples which can conduct electricity. Have you understood? These are the
Yes.
solutions which can conduct electricity. Some are acidic solution and some are basic solution which can conduct electricity. Is it clear? And all the solutions are made in water. Okay?
Yes, ma'am.
Rest of the girls, are they understanding or not? Hello, girls.
Yes, ma'am.
No answer. Yeah, are you understanding?
Yes.
Now we see effect of impurities on electrical conductivity of water. Now, if water is pure, it will not conduct electricity. That is distilled water. The water has to be impure for conduction of electricity. You agree? Agree? Water has
Yes.
to be impure for conduction of electricity. Please begin. Continue.
Although distilled water does not conduct electricity, ordinary tap water is a good conductor. This happens because the dissolved salts in the tap water increases the conductivity of water. For an electric current to flow,
Charged.
charged
Charged.
particles should move freely. These particles are also known as charge
Carriers.
carriers since they carry the charges. In the metals, the charge carriers are the electrons. In liquids, these charged particles are ions, negatively or positively charged atoms.
Fine. So what we saw in water, water is made of hydrogen and oxygen, right? It dissociates. So hydrogen becomes plus and oxygen becomes minus, and it goes to respective electrodes. So plus will go, the hydrogen will go to cathode and oxygen will go to anode and get deposited. Is it clear? Now these are called as charge carriers because they are carrying the charges. One is plus and the other one is minus. Anions and cations. What happens in the metals? These charge carriers, they are obviously electrons, so they move. When electrons move, the electricity is passing. In liquids, what happens? These are the charged particles which are taken as ions. So one is negatively charged ions, which is known as what beta? Negatively charged ions? Anions. And the positively charged ions is cations. Is it clear? Any
Cation.
problem? Yes. It is just the revision that we did earlier. Any problem? Any problem, beta?
No, ma'am.
So in distilled water, we don't have salt, so there's no free moving of electrons or any ions. So it does not conduct electricity, whereas tap water, which has got some impurities, can split into ions. Hydrogen plus will go to cathode and oxygen minus will go to anode. And you can see the
Anode.
deposition of gases on those respective electrodes. Understood better?
Yes, ma'am.
Start.
The two plates or roads through which the current enters and leaves the electrolyte are called electrodes.
So what are
The elect-
electrodes? Just a moment. What are electrodes? These are the electrodes. Can you see this? These are the
yes.
electrodes. All of you understood? And this is the blue one is electrolyte. The solution is electrolyte. Is it clear? Hello?
Yes, ma'am.
Yes. The rods are electrodes and the solution is electrolyte. You should know all these terminologies. Okay, next.
The electrode at which the current enters the electrolyte is called the anode, and the electrode at which it leaves is called the
It's
cathode.
called the cathode. Yes. Then,
The anode is positively charged while the cathode is negatively charged.
then
The arrangement consisting of a vessel, the
electrolyte
electrolyte, the electrodes, and
and
a
the
source
source of
of
electricity. And the source of electricity.
electricity.
Can you see this over here? Yes, source of electricity is battery. So what you should know that how does it enters? How does the current enters? Current enters at anode. Which is the anode, beta? Here is anode. You see this? Here. This is plus. Can you see this? This
Yes,
wire is going and it is entering anode. Now this is also plus. Hope you understood. So this is anode and this is cathode. All of you understood? And
yes, ma'am.
it enters in the anode and it leaves in the cathode. Hope you have understood how is the circuit made.
Yes,
Okay, fine. Now we'll see again the same thing, but in a different way of presentation, electrolysis. So we are just repeating it. Remember, we are just revising it again and again. Yes, electrolysis. Start.
we know that it is possible to pass electric current through water. When electric current is passed through water, it is possible to break it up into its individual components, oxygen and hydrogen.
Be a bit fast,
By,
better.
by passing electric current through aqueous common salt sodium chloride, it is possible to split it into sodium and
Chlorine. Okay.
chlorine.
Now, what we saw just now, that water is split. H2O is split into H plus and O minus. Agree?
Yes.
So we are breaking water into hydrogen and oxygen. All of you agree? All of you agree
Yes.
or not? Okay. Now we are taking the salt solution. Now what is salt made up of? NaCl. What it is made up of? NaCl. Now it is again split up. It is broken. How? In Na plus and Cl minus. Is it clear? Is
Yes.
it clear? Fine. So it is split into Na plus and Cl minus. Okay. Now say
The process by which a substance is split into its components when electric current is passed through it is called
So,
electrolysis.
electrolysis. So all
In
of you understood? We are breaking the components by passing electricity. This process or this phenomena is known as electrolysis. Any problem regarding this?
No, ma'am.
Any problem? Oh, fine. Then,
In other words, it is the chemical effect of electric current whereby electric current causes a chemical change in the substance through which it passes.
it
An
passes. So what is the
electrolyte
effect? When the electricity is passing, what is this effect? It is called as chemical effect. What it is called, beta?
chemical effect.
We saw heating effect, we saw mechanical effect. Now we are seeing chemical effect. Hope you have
Chemical
understood.
effect.
Hope you have
Yes.
understood. Okay. Then an
An
electrolyte.
electrolyte in liquid state or dissolved in water conducts the charge and
Correct,
undergoes a
beta.
change during
Hello, conducts the
electrolysis.
current. Please read properly. Conducts the charge. It's not charge. It is current.
Yeah. Conducts the current and undergoes a change during electrolysis.
What we saw that the electrolyte, which is a liquid or anything a salt which is dissolved in water, that is electrolyte, it can conduct the current. And while conducting the current, it changes. There's a change during this process, which is known as electrolysis. Any problem?
No, ma'am.
Okay. So we have done almost 4 to 5 slides on electrolysis. Things are clear, I hope.
Yes.
Purposely I did it, huh? Things are clear. Okay. Now we come to a new topic that is called as electroplating. The same electrolysis is used for electroplating. Please begin, Beta.
Electroplating is a common application of
So
electrolysis.
understood, Beta? Understood what did I say just now? That we are using this phenomena for one process, and that is called as electroplating. You get on the cycle the shiny appearance of the handle, that is electroplated. You get those utensils which you are using at home, what we call as kalai, that orange colored at the bottom of the vessels. Yes, that is also electroplating. Hope you have understood. So when you use the electricity to plate something on another metal, that process is known as electroplating. Any problem?
No, ma'am.
Next,
The process of depositing a thin layer of a metal or any conducting substance by the process of electrolysis is known as electroplating.
what are we doing? We are taking a metal. On top of that, we are putting another coating of metal. By the process of electrolysis, that is called as electroplating. Any problem?
No, ma'am.
Next,
For example,
chromium
chromium chromium
coating.
coating is done on car parts, bathtubs, wheel rims, etc. In electroplating, the object to be electroplated is made the cathode negative electrode by connecting it into the negative terminal of the battery. The metal which has to be deposited is made the anode positive electrode. By connecting it into the positive terminal of a battery, the electrolyte is usually a salt solution of the metal to be coated. On passing electric current, the object gets coated with the desired metal.
Fine. Now, what you see, the chromium coating, which is got shiny, it looks like gold. That orange is gold. It's this chromium coating is done on car parts, bathtubs, wheel rims, etc. What actually is happening in electroplating? The one which you are electroplating, let's say A, one which you are electroplating, what you make it as? You make it as cathode. What you make better? Cathode,
Cathode.
which is called as negative electrode. You agree? And what you are doing? You
Yes.
are connecting it to the negative terminal. Is it clear? Cathode is connected to the negative terminal. Now, metal which has to be deposited, where the deposition has to take place, that is made the anode, which is called as positive electrode. Is it clear? And it is
Yes.
connected to the positive terminal of battery. And what is electrolyte? You know that it is a salt solution of the metal, which is to be coated. And when you're passing the electricity, automatically the electroplating takes place. Any problem?
No,
The
ma'am.
metal starts getting deposited on the electrodes. Any problem with that? Any problem?
No, ma'am.
Here you can see anode, and here you can see cathode. It's clear?
Yes.
Hello? This is positive, and this is negative, and this is positive. This is copper. Copper is positive. Copper is positive. This will go here. Can you see? You can see the deposition. Can you see the deposition bit on the plate? The copper is deposited on cathode, and sulfate is deposited here. Is it clear? This is how the electroplating takes place. Okay? Hello. Again, we'll do the same thing for the revision purpose. Please begin.
The process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. Example for electroplating of copper as an object on an
On an
object.
object.
Yeah, ma'am, it was blurred no, I think. The
Now is it
object
okay?
is, yeah, ma'am. The object is dipped in acidified copper
Acidified.
sulfate solution, acidified copper sulfate solution and connected to the negative terminal of a battery. A copper strip is dipped in the solution and connected to the positive terminal of the battery. When electric current is passed through the solution, copper from the copper strip is deposited on the object.
So you can see over here the electroplating. Now this is a metallic spoon. They have taken as a metallic spoon over here. And this is the copper sulfate solution, which is electrolyte. Now this is electrolyte. Yes or no? This is electrolyte. Copper sulfate solution is electrolyte. We have already taken the copper strip. Now if I take the copper strip, then this is plus. You agree?
Yes.
So it is anode. Yes or no? It is anode or not?
Yes.
Yes? Understood now? So what will happen? That this copper strip will have deposition of sulfate, and this metal thick spoon will have deposition of Cu2 plus, that is copper. You understood? Did you understand better?
Yes.
For example, here you can see spoon, and this one is silver plate. You see this over here? This is the silver plate, and this is the spoon. Okay, and this silver nitrate. So what will happen? Ag plus and NO3 minus. Okay, now this silver is getting dissociated in the electrolyte in the solution, and silver will deposit on the spoon. You got my point? Thus, this silver will deposit on the spoon, and the spoon will be electroplated. Any problem?
No, ma'am.
Again, electroplating. I hope you're understanding because I've taken so many slides on the same aspect.
Yes.
Read it.
Electroplating is one of the chemical effects of electric current. Electroplating is a chemical process using which a metal is coated with a layer of another desired metal. Electroplating is done to make the metals shiny. Electroplating is done over the articles made of iron to make the iron shiny and to prevent iron from getting rusty.
There has to be some reason, isn't it? Why we are doing electroplating? Are we mad? Are we mad to do electroplating? Because electroplating is expensive. Why do we do so? First is, what is electroplating? This is the chemical effect of electric current. Do you follow me? So it is a chemical process when you get a coating of one metal onto another metal. Why do we do so? To make metal shiny, it becomes glossy. And mostly we use the iron metal. Why? Because first it looks shiny and we can avoid rusting, the corrosion. Do you understand?
Yes.
Yes. Let's see the example.
Example, wheel runs, handle of
Rims.
cycle, wheel rims, handle of cycle, etc. are made shiny by the method of electroplating.
You can see over here, these are rims of wheel. These are the handles. You can see this. You can see the
Yes.
gadgets, the washroom gadgets, and you can see the lock and key. So all these things are galvanized, rather electroplated. Is it clear? Is it clear better?
Yes, ma'am.
Again, the same thing, process. I think I will not repeat it again. You will understand. If you have understood, you can let me know. We can go to the next slide. Is it clear? Please.
Okay. In the process of electroplating, metal salt solution is taken in a container.
So what is
Salt
the
of
metal salt
metal.
solution? Delisha, what is the metal salt solution? What is the other name of it? Can anyone tell me? What is the name of metal salt solution? Be fast. Where are you? It is electrolyte. What it is? Hello?
Electrolyte.
Why you keep quiet? I don't understand. Huh? If I'm asking you a certain question, I need answer. Okay, then
Salt of metal is
chosen.
chosen which is to be coated over another metal. Metal which is to be coated is dipped in the solution and connected with negative pole. Metal for desired coating is connected with positive pole.
So understood now? Here it
Yes.
is. See, this is how you have to make the circuit. Now, what is it? Read. Read
When
better.
electric current is passed through the solution, matter from anode is dissolved in the salt solution and deposited over the negative pole cathode. Thus, coating of desired metal is obtained on another metal.
Okay. So electric current is passing the solution. Metal from anode. Which is anode better? This is anode. This is plus, and this is
Yeah,
negative, isn't it?
this is cathode.
Yes. So metal from anode is dissolving in solution. And where does it get deposited? On the negative pole, that is cathode. Is it clear? So we get a coating. We get a desired coating of another metal on that electrode. Okay? Now what are the uses of electroplating? Please.
Electroplating is used in industry for coating metal objects with a thin layer of a desired metal.
Then
Chromium has a shiny appearance and it does not corrode.
corrode.
Chromium corrode. Ma'am, what is meaning of corrode?
I will tell you, I will teach you everything. Finish it first.
Okay, ma'am. Chromium plating is done on objects like bicycle parts, ca- car parts, taps, gas burners, wheel rims, etc. Jewelry makers
Yes.
electroplate gold and silver on less expensive metals to give an experience of gold or silver.
Appearance. It is not experience, it is appearance.
Appearance of gold or silver. Tin cans used for storing food are electroplated with tin over iron because tin is less reactive than iron and protects iron from corrosion.
Corrosion. Corrosion.
corrosion. Iron objects are coated with zinc to protect it from corrosion.
Fine. The same examples, so no need to uh, explain because I've already taught you. Now, what are the uses? One by one, we'll deal with it. Now, it is used in industry. Why? Because we are coating the metal objects with a thin layer of a metal that we want. That is first usage in industry. Second, we know chromium is very glossy, it's very shiny, and it does not corrode. Corrode means it does not rust. You got it now?
Yes, ma'am.
Yes, it does not rust. So chromium plating we do on objects like bicycle parts which are made of iron, car parts, taps, gas burners, wheel rims. So we do the chromium electroplating on all these metals to avoid corrosion, to avoid rusting. Third, we also make jewelries. What we do electroplating of gold and silver on less expensive metals and show it as if it looks the real. It looks real, like gold and silver ornaments. But actually, it is not. It is with 1 gram gold. I hope you know that 1 gram gold jewelries. Hello, have you heard of one
Yes.
gram gold jewelry? So they do just a coating of gold onto the less expensive metals. Okay. Now we have a tin cans. Now at home you can get those tin cans with stored food, preserved food. Yes. So this tin cans they're used for storing food, but we know that iron reacts with food very much. So what we do, we coat the iron metal with tin because tin is less reactive than iron, and the taste of the food remains as such for long period of time. So we are using in tin cans also electroplating. So we are electroplating iron with tin. The last one is iron objects are also coated with zinc. The handle of a bicycle is zinc coating. I hope you know that. So again it so as to protect it from rusting or corrosion. Say any problem?
No, ma'am.
You can read this uses of electroplating. Just for the revision's sake, we have already done it. Please read. So you hope you
Water.
understand what I have done. I could have
Yes.
finished this chapter long back, but I'm repeating it so many times so that we don't have to revise again. Right now only you are doing revision. Is it clear?
Yes.
There's a reason that I took so many slides for one topic. Okay, start better.
Water pipes, which are made of iron, are coated with a layer of zinc metal by the process of electroplating. Zinc is less reactive than iron and thus prevents the iron pipe from getting rusted.
Understood? So iron pipe are coated with zinc by electroplating. Agree?
Yes.
Okay. Okay. Now second.
Rims
Be
of wheel
fast.
of cycle, cars, etc. are electroplated with chromium metal
Chromium.
layer of chromium
Okay.
metal give them shiny appearance and prevents from rust.
Any problem?
No, ma'am.
Okay. Next.
Ornaments made of silver or other cheap metals are electroplated with gold to give them appearance like gold.
Any problem in this also?
No, ma'am.
So it's revision. I don't think you have to revise it
Yes.
again. What do you say? Okay.
Yes.
Last one.
Tin cans used for storing food are made of iron ec-
Okay.
electroplating with a coat of tin. Tin is less reactive than iron and prevent foods packed in them from getting spoiled.
Is it okay? Is
Yes.
it okay? So we are through this chapter. Okay. Should we start with the next chapter, better? I've got still 10 minutes. We can finish at least 5, 6 slides of less than 15.
Okay,
What do you
ma'am.
say?
Yes.
Do you have any problem regarding this chapter now? Tell me.
No, ma'am.
Yes, girls, let me know. Let me know, better. If you have any problem regarding this slide, tell me.
No, ma'am.
Girls, okay. Only one answer, Delisha. Only you are the one who is answering. I would have been glad if all of you, should have said yes.
No.
Start with a new chapter. Lesson number 15, some natural phenomena. So let me continue first. In this chapter, we are going to explain about the topics, that is introduction, lightning. Please see the spelling of lightning, okay? Earthquake, electrical charge, transfer of charge, electroscope, and seismograph. So these are the topics that we are going to deal with. Now, introduction. What it is all about of the natural phenomena. Please begin with it.
A natural phenomena is not a man-made event. Examples include sunrise, weather, biological processes, physical processes, tidal flow, and include natural disasters such as electromagnetic pulses,
Pulses.
uh, volcanic eruptions, earthquakes.
Then
Various types of natural phenomena occur, including the following: geological phenomena, volcanic activity, and earthquakes. Mm. Meteorological
meteorology.
phenomena. Ma'am, what is this?
Hurricanes. Hurricanes.
Hurricanes, thunderstorms,
Thunderstorms
and
and tornadoes.
tornadoes.
Oceanography.
Ocean,
Oceanographic
oceanographic phenomena.
phenomena.
Tsunamis,
Tsunamis.
ocean currents, and breaking waves. Exposure to forces of nature resulted in about
2 lakh
2 lakh
14,000
14,000
deaths.
deaths
Deaths
in
in 2010.
2010, up
Up from
from 31 lakh in
31,000 beta.
1990.
It is not lakh, it is thousand.
Sorry, ma'am, 31,000.
31,000 in. So it is up. That means it is increasing. So it has to
Yes,
be less than that number. Is it clear? Oh, fine. Doesn't matter. It goes, it happens. Don't worry about that. What is introduction? What is natural phenomena but we are not making it. Are we making this natural phenomena? No, nature is making it, isn't it? Nature is making it. For example, sunrise. Do you have any control over sunrise? Can you
no,
control weather? Can you control the biological processes that is happening inside your body? Can you control that? Can
no,
you control your
ma'am.
respiration? Can you control your digestion? Can you do that? No, you cannot do that. Can you control the tidal flow? Can you control the disasters, for example, volcanoes, earthquakes? We can't do anything about all these things. Okay? Because nature is supreme. The types of natural phenomena occur. There are mainly three types. First is geological phenomena. Now, as the word suggests, geo. Now, geo means earth. What is geo, beta? Earth.
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 This is how you have to remember. Geo means earth. So anything related to earth is called a geological phenomena. First is volcanic activity and the second is earthquake. Agree? Girls, do you agree?
Yes.
Hello? Okay. Now second we will come to meteorological phenomena. When we talk about meteorological phenomena, that means the atmosphere around us. What is it, beta? Air. Atmosphere around us. That is air. What it contains? Hurricanes, cyclones, thunderstorms, tornadoes. Understood?
Yes, ma'am.
Yes? Okay. The third one is concerned with ocean or oceanographic phenomena. What are these? Tsunamis, the currents, and the breaking waves. These causes lots of damage to the people as well as property. Is it clear? Now, what it shows that the forces of nature, if we are exposed, we are at the mercy of nature. So there was death of 2,14,000 in 2010. It had increased, remember, from 31,000, which was in 1990, it soared high to 2,14,000 in 2010. Do you understand why it is increasing? Now nature is playing with us. We played with nature. Now it's the time that nature is playing with us. Is it clear?
Yes, ma'am.
Okay. Now see what is lightning. See, look at the spelling of lightning better. What you people do, you put E inside. Never do that. That is lightening. This is lightning, and that is lightening. Now, lightning means to make it less heavy. What did I say? This lightning will be less heavy. Is it clear? Is it clear?
Yes,
And when
ma'am.
I talk lightning, it is spark. What it is, beta? Spark. Is it clear? Now you
Yes.
got the difference by just one simple E. You can see the meaning completely changes. So don't ever try to, uh, what should I say, be careless about writing the right spelling. Is it clear?
Yes, ma'am.
Fine. Let's see what is lightning. Please continue, beta.
Lightning is a powerful sudden flow of electricity accompanied by thunder that occurs during an electric storm. The discharge will travel between the electrically charged regions. The charged regions within the atmosphere temporarily equalize themselves through a lightning flash, commonly referred to as a strike if it hits an object on the ground. It was Benjamin Franklin who first discovered that lightning was electric discharge.
Okay. Now, what is lightning? Suddenly, you get a flow of electricity, and along with flow of electricity, you hear thunder. That means there is a storm which is approaching. Yes. Now, what is this? This is discharge. This is a discharge of electrons in the atmosphere, which is making it spark. The charged regions, which could be within the atmosphere, it could be with the clouds and the earth, or it could be between the two clouds. You understand? If two clouds there is a friction, you can get lightning. If there's a friction, like the lightning, the electrons passes from cloud to the earth, you can hear the thunder as well as you can see the lightning which is falling from the cloud to the earth. You got it? That is called
Yes,
as
ma'am.
lightning flash. And the word that we are using is strike because it can hit an object. That object could be an animal, it could be a tree, or it could be a house. There are cases when the house catches fire if the electricity falls on them. Now, who was the first person? Benjamin Franklin was the first person to observe, to discover that lightning actually was nothing but it was electric discharge. Is it clear? Hello? This
Yes,
is how
ma'am.
it looks. See, this is how it looks. Can you see this? It is
Yes.
falling down. It's falling down. So this is called lightning. Okay. Have you understood the new chapter that we have started with? I'm not
Yes,
asking
ma'am.
about the last chapter, lesson 14. I think you have very well understood lesson number 14. But we started with lesson number 15. I didn't have any other option, beta, because we are short of time. So I feel that as soon as possible, we will wind it up. Okay?
Okay, ma'am.
Because again, Tuesday is holiday. The Tuesday is holiday, 26th January. I hope you know that.
Yeah.
That's why
Yes.
again we are going to miss out certain lectures. So that's the reason that I thought that it's better on Monday we will at least make it half. Okay? And please be sharp on time. Okay? I hope
Yes.
you have understood this chapter a bit. Yes, beta?
Yes, ma'am.